Hi everyone, we're going to work on some of the questions of the rational functions review. The first question is asking which of the following is a rational function? We know that a rational function is basically the ratio between two polynomials, one on top and one in the bottom. So if I want to know which one is a rational function, basically I need to look for a polynomial in the denominator. And look at the first one, third, and the fourth one. They all have only a number in the denominator. This is the only one that has an x in the denominator. That means there's a polynomial in the denominator. So this is a rational function. The next question is asking us to find the features of the function, this rational function. So the first step is always factoring. You need to factor this function first. Look at the top of the function. There's a trinomial here, 3 terms here. Always, if you have trinomial, you're going to look for this method, the big X method, two numbers that add up to the b value, which is 5, and multiply to a times c. 3 times 2 is 6. Those two numbers are 2 and 3. So you're going to split the middle term using these two numbers. So I'm going to write 3x squared. Instead of 5x, I write 3x plus 2x. And the last term is going to be written here. Now, look at the first group. You're going to group them, first group and the second group. The first group, 3x is in common between them. So you factor 3x out and divide this by 3x. The 3's cancel. X squared divided by x is x. And 3x divided by 3x is 1. Okay. The second one, 2 is in common between them. So you're going to factor the 2 out. This divided by 2 is 2. It's x. This one divided by 2 is 1. As you see, x plus 1 is in common between them. So this time you factor x plus 1 out, and from the first group, if you factor this one out, 3x is left. The second group, if you factor this one out, only 2 is left. So this is the factor of the top, x plus 1, 3x plus 2. And now let's look at the bottom of the fraction. We have x squared plus 3x plus 2. This time, you're going to look at two numbers, find two numbers that add up to the b value, which is 3, and multiply to a times c. 1 times 2 is 2. Those two numbers are 1 and 2. So again, split the middle term using these two numbers, x squared plus x plus 2x plus 2. So the middle term is written as x plus 2x. Now, first group, x is in common between them. So if I divide this by x is left. This divided by x, 1 is left. The second group, 2 is in common between them. This divided by 2 is x. This one divided by 2 is 1. Now, x plus 1, you factor that out because it's in common between them. If you factor this one out, only x is left. If you factor this one out, only 2 is left. So the factor of the bottom is x plus 1 times x plus 2. Now, as you see, there is a twin factor on top and the bottom. They cancel each other. And your remain function is 3x plus 2 over x plus 2. This is your remain function. And notice that here you cannot cancel the 2's or x's here. No, because they're stuck with the plus between them. You cannot cancel anything anymore. So this remain function is going to be your function from now on. Only look at this one to find the other features. To find the removable discontinuity or the whole of your function, set the cancelled factor equal to 0. X plus 1 equal to 0. Subtract 1 from both sides, and x is equal to -1. This is the whole of the x of the whole. To find the y of the whole, plugging this into the remain function. So 3 times negative 1 plus 2, and this x is also negative 1 plus 2. 3 times negative 1 is 3, negative 3 plus 2 is negative 1. Negative 1 plus 2 is 1, so it's negative 1. So negative 1 and negative 1 is the whole. X-intercept. To find x-intercept, you need to set the top equal to 0. What is the top of the function? Top of the remain function is 3x plus 2. 3x plus 2 equal to 0. You subtract 2 from both sides. 3x is equal to negative 2 and divide by 3. And x is equal to negative 2 over 3. So the x-intercept is negative 2 over 3 and 0. To find the y-intercept, you're going to set the x equal to 0 and plug that into the function. So y-intercept will be 3. Wherever you see x, replace that with 0 plus 2 and 0 plus 2. Okay, this is 0 plus 2 is 2. 0 plus 2 is also 2. It's equal to 1. So the y-intercept is 0 and 1. Then, to find the vertical asymptote, you set the denominator equal to 0, or the bottom equal to 0. The bottom of the fraction, the remain fraction is x plus 2. Subtract 2 from both sides, and x equal to negative 2 is the vertical asymptote. Then we need to find the horizontal asymptote. We know that in order to find the horizontal asymptote, we need to know the degree of the top and degree of bottom. Okay, what's degree of the top? The term with the highest power, that's this one. So the power of that is 1. Degree of the bottom is also 1, the term with the highest power. Because if you have a constant term, the constant term has a power of 0. So that's not the highest one. So it's just 1 over 1. N is 1 and V is 1. They equal to each other. And we know that if they equal, the asymptote is leading coefficient of top over leading coefficient of the bottom. What's leading coefficient of top? That's 3. For the bottom is 1. If you don't see anything, it's 1. So it's 3 over 1. This is the horizontal asymptote. Okay, let's go to question number 4 here. It's asking us to find the horizontal asymptotes here. As you know, we always need to know the degree of top and the bottom. Degree of the top for the first one is 2. For the second one, I'm sorry, the bottom, the top is 2, the bottom is also 2. The term with the highest degree, 2 and 2. They are equal to each other. So the asymptote is leading coefficient of top over leading coefficient of the bottom. What are leading coefficients? For the top, the coefficient of the term with the highest degree is 1. For the bottom, coefficient of the term with the highest degree is 2. So 1 over 2 is the asymptote, horizontal asymptote. The second function, degree of the top is 1, because it's x to the power of 1. Degree of the bottom is 3, because x to the 3 is the term with the highest degree. So this is bottom heavy. If it's bottom heavy, the asymptote is y equal to 0. Next one, degree of the top is 3, and degree of the bottom is 1. And when you compare them, this one is top heavy. If it's top heavy, There is no horizontal asymptote. Okay, now we're going to look at question number 6, and we want to graph this function. In order to graph, first we need to factor. Look at the polynomials on top and the bottom. They are not trinomial. They are not 3 terms. They are both 2 terms, and they all are perfect squares. Difference between perfect squares, because the top is 4x squared minus 1. 4x squared is 2x times 2x. 1 is 1 times 1. So they're both difference between the perfect squares here. So you're going to factor that as 2x minus 1 and 2x plus 1. This is the top. And the bottom is x squared minus 9. This is again x times x, and 9 is 3 times 3. So you're going to factor as x minus 3 and x plus 3. So the factored form will be 2x minus 1, 2x plus 1, and x minus 3, x plus 3. There is no factor that is repeated on top and the bottom, so nothing cancels. That means there will be no removable discontinuity or hole in the function. Vertical asymptote, you're going to set the denominator equal to 0, x minus 3 and x plus 3 equal to 0. So x minus 3, x plus 3 equal to 0. Set the bottom equal to 0. Now in order to solve, because this is in factored form, you set each factor equal to 0. So add 3, x equal to 3. And this one, x plus 3 equal to 0. Subtract 3, and x equal to negative 3. So these are the two vertical asymptotes. To find the horizontal asymptote, you need to know the degree of the top and degree of the bottom. It's easier if you want to find degree of the top and the bottom. It's easier if you look at the original function, not the factored form. The standard form is easier. Degree of the top is 2, the term with the highest degree, so that's 2. Degree of the bottom is also 2. So they are equal to each other. That means the asymptote is leading coefficient of top over leading coefficient of the bottom. What's leading coefficient of top? It's 4, and the bottom is 1. 4 over 1, so y is equal to 4. That's the horizontal asymptote. Then a slant asymptote, there is no slant asymptote because we have a slant asymptote only if the degree of top is 1 more than the degree of the bottom, but they're equal, so there's no slant asymptote. To find the y-intercept, you're going to set the top equal to 0. The top is 2x plus 1 and 2x minus 1. So if we set them equal to 0, that means you need to set each factor equal to 0 to solve for x. So 2x minus 1 equal to 0. So I'm going to add 1 to both sides. This is 2x equal to 1, and then divide by 2. So x equal to 1/2. So 1/2 and 0 is 1 x-intercept. The other one, 2x plus 1 equal to 0, because we had 2 factors that each of them equal to 0. And from here, again, you subtract 1 and then divide by 2, x equal to negative 1/2. So negative 1/2 and 0 is the other x-intercept. To find the y-intercept, you plug in x equal to 0 into the function and find the y. You can plug in x equal to 0 into any of these, like the original function or the factored form. I think the original one is easier because there's going to be less operations. Just plug in x to the 0 x equal to 0 into the original function, the standard form. So it was 4 times x squared minus 1, and the bottom was x squared minus 9, but your x is 0. Okay, so these two, 4 times 0 squared is 0, minus 1 is -1. This is also 0 minus 9 is -9. So your y-intercept is 0 and 1 over 9 because the negatives also cancel. Okay, so we're going to graph the function and then we find the domain and range. We have asymptote, vertical asymptote at 3. So there's one here, and there's another one at -3 here. Okay. There is a horizontal asymptote at 4. 1, 2, 3, 4 here. This is our horizontal asymptote. We have x-intercept at 1/2 and -1/2. So there is one x-intercept here, another one here. And y-intercept is at 0 and 1, 9. So that's going to be a small number over here, 1, 9. Okay, now I need to start graphing my function. I know that one part of the function has to cross these 3 points and get close to the asymptotes close to them. So the one part of the graph is going to be this. Get close to the asymptote and then pass these and go here. So this is one part. But we have more curves. We know that the rational function has at least 2 curves. What is the other part of the graph? I have only the part of the graph which is for the x values between these two. But I don't know what is happening before this x-intercept and after the other x-intercept. These areas, we don't know yet what is happening. I need to know if the curve is going to be on top or bottom, here or here, which one. So I need to decide that. What do I do for that? You need to plug in one x value in this area into the original function. So I'm going to choose this. You could choose any of the others. Anything in this area before the x equal to -3. So this is -4. I plug that into the function. So f of -4 will be 4 times -4 squared minus 1 over -4 squared minus 9. So this will be, the top will be 63, the bottom will be 7, that's 9. So when x is -4, y is 9. That's going to be almost here. So I know that for this part of the graph, the curve is going to be here between these two asymptotes, get close to asymptotes and pass this point. So this is one part. Now, what is happening on this side? Again, plug in one value of x. Here I choose x equal to 4. Should be something after x equal to 3. So I chose 4 into the function again. So what is f of 4? That's going to be 4 times 4 squared minus 1 over 4 squared minus 9. That's again 63 over 7, which is 9. So when x is 4, y is again 9. So the other part of the graph is going to be this. Sorry, I'm going to erase and do it again. Okay, so this is my graph. Now we're going to look for the domain and the range. I'm going to write them here. For the domain, you are moving from left to the right and looking for x values. As you see, for all the x values, you find a value on the function. You find something on the curve. Everything is defined except that the vertical asymptotes. Those are the points that the function are not defined. We know that these are discontinuities of the function. So I know that the function is not defined on these two. So I go from -infinity to -3. This was -3 to -3. At -3, we have to make it jump because the function is not defined and continue after that. So I'm going to use this union sign, -3, 2. Again, at 3, there is another asymptote. So we have to make another term, 3. And after 3, everything is again defined. So it's 3 to infinity. So this is the domain. How about the range? You're moving from bottom to top and looking for the y values. Start from the bottom and you see that everything is defined, everything defined here until this point. The y value of this point was 1/9. So I say from -infinity to 1/9, function is defined, and then here nothing is defined, and the asymptote which is at 4, you know that function also is not, the y values are not defined at y equal to 4. So the second part of the function starts from 4, and after that everything is defined. So 4 to infinity. This is the range. Okay, let's look at this function. First, we're going to factor the function. The top of the function, the first thing that I see is that x is in common between them. So I have x times x squared minus 25 because I'm factoring the x out. X to the 3 divided by x is x squared, and 25 divided by 25x divided by x is 25. So this is the first step of factoring. But we can factor this more because x squared is x times x, and 25 is 5 times 5. So this is itself another polynomial that could be factored. This is the difference between two squares. So it could be, I'm going to write the first x here, and the second part could be written as x minus 5, x plus 5. That's how you factor the second part. So this is the top. And the bottom, you're looking for two numbers that if you add them, you get -4. If you multiply them, you get -21. 3 and 7 multiply to -1. If this one is negative, they add up to -3. So I can factor using these two numbers, x squared minus, I'm going to split the middle term using these two terms, minus 3x, plus 3x minus 7x minus 21. The first group, 3 is in x is in common between them. So if I factor x out, x squared divided by x is x, 3x divided by x is 3. The second group, -7 is in common. So you factor -7 out, -7x divided by -7 is x. This divided by -7 is 3. So x plus 3 is in common between them. And then if you factor this out, the first one, x is left, factor this one out, the second one, -7 is left. So the bottom is x plus 3, x minus 7. I'm going to rewrite that here. Nothing cancels out from top and the bottom. There's no twin factor, so there's no removable discontinuity. To find the vertical asymptote, you set the denominator equal to 0. Denominator has two factors, so x plus 3 equal to 0. If you solve, x equal to -3. X minus 7 equal to 0. If you solve, x equal to 7. Horizontal asymptote, you need to look at the degree of the top, which is 3. Degree of the bottom is 2. So this is top heavy. That means there is no horizontal asymptote. Now, do we have vertical, do we have slant asymptote? Yes, because degree of the top is exactly 1 more than the bottom. So I can have a slant asymptote. So how do I find the slant asymptote? You need to divide the top by the bottom. I'm going to divide the top by the bottom here. Okay, so in order to divide the top by the bottom, I'm using the long division because the denominator is not linear, I have to use only long division. So first of all, I see that there is a missing term here, so I have to add the missing term here, and that's x squared. So I write plus 0x, and then I had minus 25x. I'm sorry, this was 0x squared. The x squared term was the one which was missing. Okay, now I'm going to start division. Divide the first term by first term. X to the 3 divided by x squared is x. So now you're going to multiply x times x squared is x to the 3. X times negative 4x is negative 4x squared. X times negative 21 is negative 21x. Okay. Now you're going to subtract x to the 3 minus x to the 3. They cancel. 0x squared minus negative 4x squared will be positive 4x squared. Negative 25x minus negative 21x will be negative 5x. Now divide 4x squared by x squared. It's equal to 4. See, 4x squared divided by x squared. These cancel and it's equal to 4. So write 4 here. 4 times x squared is 4x squared. 4 times negative 4x is negative 16x. 4 times negative 21 is negative 84. Now we're going to subtract them. 4x squared minus 4x squared, they cancel. Negative 5x minus negative 16x will be positive 11x. And then here you have negative 84. That is basically 0 minus negative 84. That's positive 84. Now, the remainder is what we're going to ignore. We don't need the remainder. We only need the quotient. That's our horizontal asymptote. So y equal to x plus 4 is the horizontal, the slant asymptote. Okay, so you divide top by the bottom, ignore the remainder, the quotient is your slant asymptote. Okay, so we found the slant asymptote. Now let's go and find x and y intercepts. So to find x-intercept, you're going to set the top equal to 0. Top has 3 factors. Set each of them equal to 0. So the first one, x equal to 0. Next one, x plus 5 equal to 0. And from here, x equal to negative 5. And then we also had x minus 5 equal to 0 and x equal to 5. So we have 3 x-intercepts, 0 and 0, 5 and 0, negative 5 and 0. These are the x-intercepts. What are the y-intercepts? You need to set the x equal to 0 and plug it into the function. It's easier if you plug that into the original function because it has less operations than this one. So the original function was x to the power of 3. So I write 3 to the power of 3 minus 25x. So that's 25 times 0 over the denominator is x squared minus 4x minus 21. So it's 0 squared minus 4 times 0 minus 21. Okay, so 0 squared, 0 to the power of 3 is 0. 25 times 0 is 0. So the top is 0. The bottom, these are 0, and there's only negative 21 left. However, 0 divided by anything is 0. So the y-intercept is at 0 and 0. Now let's start graphing the function. We have a vertical asymptote at negative 3. So here at negative 3, we have a vertical asymptote at negative 3. And then we have another vertical asymptote at x equal to 7. So 1, 2, 3, 4, 5, 6, 7 here. This is the other vertical asymptote. There's no horizontal asymptote, but we have a slant asymptote. How do I find the slant asymptote? How do I graph that? We know that this is the slope. Basically, the coefficient of x is the slope, and the number here is the y-intercept, because the general form of a linear function is mx plus b. M is the slope, the b is the y-intercept. So m is 1, b is 4. So we're going to start from here. From y-intercept, which is at 4 here, I'm going to go 1, because the slope is 1. 1 rise, 1 run. Rise over 1 is 1, 1, 1, and so on. So this is our slant asymptote. So I'm going to graph a line that passes these points. Okay, I'm going to move that here. A slant asymptote that passes these lines. So this is my slant asymptote. Then we have x-intercept at 0 and 0. 1 is here. Then 5 and 0, that's here. And also -5 and 0, which is here. If I can see it well, 1, 2, 3, 4, 5, yes. So this is -5. These are the x-intercepts. We have a y-intercept, which is also at 0 and 0, so they are on the same place. Okay, now I'm going to start graphing my function. Between these two asymptotes, I have these 2 points. So my graph is going to cross these 2 points and get close to the asymptotes this way. This is 1 point. Between these two asymptotes, I have this point. That means the graph is crossing this point and gets close to the asymptotes here. This is the other one. And now on this area, I don't know if the curve is going to be here or here. How do I know that? I'm going to plug in one value into the function. I'm going to plug in x equal to 10 and see if x equal to 10, what is the value of the function. So f of 10 will be 10 to the power of 3 minus 25 times 10. 10 squared minus 4 times 10 minus 21. Okay, 10 to the power of 3 is 1000 minus 25 times 10 is 250. So the top will be 750. The bottom 100 minus 40 minus 21. That's going to be equal to, if I'm not mistaken, it's 40. It's going to be 49. And 750 divided by 49, if I use my calculator, is equal to 15.3 almost. So when x is 10, y is 15.3. Where is 15.3? It's going to be somewhere around here because it's 11, 12, 13, 14, 15.3. So it's going to be somewhere here. Almost here. So I know the other part of my graph is between these two curves here. So this is the curve. Okay, now I need to find the domain and range of the function. I'm going to make some space here to find the domain and range. I'm going to write them here. So the domain, you look from left to the right and look for the x values. And as you see, everything is defined because there's no removable discontinuity as well. There's only the vertical asymptote. The function is defined everywhere except at -3 and 7 because they are the vertical asymptotes. So you're going to write from -infinity to -3. There is a jump here, and then from -3 to 7, and because everything is defined here, and at 7 we jump, and 7 to infinity, everything is defined. Then for the range, you're going from bottom to top looking for the y values. And here there's no horizontal asymptote. And as you see, for all the y values, the function is defined everywhere. The slant asymptote doesn't make any problem for the range. It doesn't discontinue. It doesn't make any discontinuity in your range. So the range is going to be everything from negative infinity to infinity. There's no horizontal asymptote, so it's just negative infinity to infinity. Okay, let's look at question number 13. So we want to look for the end behaviors. The end behaviors are all these parts of the graph. All these are the end behaviors. And I want to know what is happening to x and y of the function at these ends. On the left side here, as you see, if you continue the function, x is going to go to negative infinity. So that's this part, x going to negative infinity. But what is the y doing? Look at the graph. It's getting close to this line, but doesn't pass. What is this line? It's at y equal to -3. So x goes to negative infinity, but y gets close to this line, doesn't pass that, so you just write -3. On the other side, if you continue the x is going to increase and go to positive infinity. And what is y doing? Again, it's getting close to this line, which is at -3. So horizontal asymptote always defines the end behaviors when x goes to infinity, positive or negative infinity. And then let's look at these ones, this one and this one. On this side, as you see, the vertical asymptote is at x equal to -2. The graph is getting close to this -2. The x of this graph is getting close to -2, but doesn't pass. And also it's getting close from the left side. So you're going to write for this one, x close to -2 from the left side. The negative means from the left side. So that's this part. What is the y doing? It's just going down. It continues going down. So it's going to negative infinity. So that's this one. On this side, again, your x is getting close to the asymptote, which is at -2, but from the right side. So you write x goes to -2 from the right side, little positive on top. So that's this one. And what is y doing? It's increasing, it's going up to positive infinity. So that's this one. Now, how about this one? You know that the asymptote here is at 3. X equal to 3 is the vertical asymptote. Now, on this side, what is happening? The x is getting close to this value, 3, from the left side. So you write 3 negative on the top. That's this one. What is the y doing? It's going down. It's negative infinity. On this side, x is getting close to this asymptote, but from the left side. So you write x goes to 3 from the, this one from the right side. So you write a plus here. And what is the y doing? It's going to up and it's increasing. So it's going to positive infinity here. You can write positive infinity or just write infinity. Okay, now I'm going to find the domain of the function. So for the domain, you're going to write it's covering everything except that the vertical asymptotes, and there's no hole here as well. So it's just negative infinity to -2. There's a jump at -2, and then we go to 3. So -2 to 3, everything is defined, and then 3 to infinity. That's the domain. For the range, you're going from negative infinity, and there's a jump at -3 here. This is the horizontal asymptote, and after that, again, everything is defined. So for the range, it's negative infinity to -3 and -3 to infinity. And here's the last question that we're going to work. we have the graph and we want to write the equation of the function at the end. Okay, so vertical asymptote is at x equal to 1. So x equal to 1 is the vertical asymptote. Horizontal asymptote is at 0.2. So y equal to 0.2 is the horizontal asymptote. So you see this x is the vertical asymptote, the y value is the horizontal asymptote because the horizontal line is missing. Okay, so vertical asymptote is at x equal to 1. Horizontal asymptote is at 0.2, which you can write it as 2/10 or simplify it as 1/5. So your horizontal asymptote is y equal to 1/5. Just simplify the 2/10. X-intercept is at 10 and 0. This is where the graph is crossing the x-axis. Y-intercept is at 0 and 2. The whole of the function is here. This is the whole of the function, which is at -2 and 0.8. -2 and 0.8. Okay, so what's the domain of the function? This time, if I want to find the domain, I'm going to write the domain here. You look from left to the right, and as you see, everything is defined except at this point, there's a hole, the function is not defined. And after this point, everything is defined. So you write from -infinity to x of the whole, which is -2. And then after -2, it's defined until we reach to the x and to the vertical asymptote, which is at 1. So at 1, we have to make a jump. And after 1, everything is defined. So this is the domain. What is the range of the function? You go from bottom to top. Everything is defined except at the horizontal asymptote. So you're going to write -infinity to 1/5 or 0.2. After this point again, everything is defined. So we have a jump at 1/5. And then again, at this point, the y of this point, the function is not defined. So 0.8 is not defined. After 0.8, it is again defined. So you need to make sure you exclude the x and y of the whole from the domain and range, 0.8 to infinity. So this is the range of the function. Okay, now we're ready to write the equation of the function. I'm going to write that here in the middle. So we know that if we have vertical asymptote, the vertical asymptote comes from a factor in the denominator. So I'm going to write if x equal to 1 is the vertical asymptote, x minus 1 was the factor that created that. So x minus 1 is in the denominator. Then we have x-intercept at 10 and 0. We know x-intercept comes from setting the top of the function equal to 0. So if x equal to 10 is your x-intercept, x minus 10 was the factor that created that. So you write x minus 10 on the top. Then there was a removable discontinuity at -2. And we know that removable discontinuity comes from a factor which is repeated on top and the bottom. So the factor that created this was -x minus 2. This should be repeated on top and the bottom. Then the horizontal asymptote is at 0.2, or we just said it's basically 1/5. If the asymptote, the horizontal asymptote is a number, that means this was basically leading coefficient of top over leading coefficient of the bottom, because as you see, the degree of the top is 1 plus 1, 2. Degree of the bottom is again 1 plus 1. That's also 2. So they're equal. That means it's leading coefficient of top and the bottom. Leading coefficient of the top is 1, and obviously it's right here because 1 and 1, multiply them, it's going to make 1. But the bottom is 1 and 1. It should be 5. So how do I make it 5? Just add a 5 here. Multiply 5 by this factor. So this is going to be your function. The asymptote, the horizontal asymptote is 1 over 5. Vertical asymptote is at 1. X-intercept is at 10. Pole is at 2. Okay, so this is a short review of rational functions. Good luck on your test.